is actually, suppose my set is actually open 0, 1, open, closed, dense, perfect, bounded, right? So these are the features. In first metric, suppose this is my first metric, this is my second metric. Suppose that this is my D1, this is my D2. First answer, first question for this set. Suppose my set is open 0, 1. Question is it open in D1 in discrete? Is it open in discrete? D1 means discrete. Is it open?
Yes, sir.
Yes, because I already told you any subset of a discrete metric space is open. The answer yes. Is it closed in discrete? Yes or no? See, any subset, you start with any subset of a discrete metric space is always open. Any subset of a discrete metric space is always open as well as closed in discrete. So therefore, is it closed in discrete? Is it closed in discrete? Because it's a subset of R now. Any subset of R is both open as well as closed in discrete. So is it closed? E equals to open interval 0, 1. Is it closed?
Yes, sir.
Yes, because it is after all a subset of R now. Any subset of R is closed, right? With respect to discrete. Yes or no? Is it dense in discrete? Is it dense in discrete? You know that actually E is closed in discrete, therefore E closure is equals to E, but not R, right? E is a closed set in discrete, therefore E closure is equals to E. E cannot be R, therefore E should not be dense in discrete. Is it clear? Hello? Is it clear?
Yes, sir. Carry on.
Yes. Suppose, is it perfect? Is it perfect? Is it perfect in discrete? The answer. What are the limit points of T? Empty. In discrete, the limit points are empty. Yes or no? The limit points are empty because you take any point, I can adjust a neighborhood as a singleton. That singleton does not contain any point other than itself. Therefore, any neighborhood you take, it contain neighborhood as a singletons. So therefore, neighborhood does not contain other point. Therefore, it has no limit points. So what are my limit points in discrete? Empty set. So is it equals to E? No. Therefore, it cannot be perfect. Right? Is it actually bounded? Is it actually bounded in discrete? Is it bounded? My set is actually open 0, 1. Is it bounded? Is it bounded? The answer yes, because discrete is always less than or equals to 1 for every x comma y belongs to E. So 1 is less than 2. Therefore, what I take is that actually this distance between x comma y is less than 2 for every x comma y belongs to E. Yes or no? Distance between x comma y is less than or equals to 1. Because actually, what is my distance function? What is my distance function? My distance function is discrete. This is either 1 or 0. Therefore, it can be less than or equals to 1. Therefore, 1 is less than 2. Therefore, distance between x comma y less than 2 for every x comma y belongs to E. So I can take, see, this is what is my set? My set is open 0, 1. So I can take actually in particular, I can take y equals to suppose 0.5 is less than 2 for every x belongs to open 0, 1. Therefore, distance between x comma y is less than 2 means what? X is contained in the ball center at 0.5, 2 for every x belongs to 0, 1. Right? So therefore, any point you take in the set that is in the ball, that means what? This is contained in the ball center at 0.5, 0, 2. But what is this? This is nothing but E. Therefore, E is contained in some ball center at 0.5 with radius 2. Therefore, what? E must be bounded because E is contained in some open ball centered at 0.5 with radius 2. Not only this is true for open bounded interval. You can take A equals to R also. You can take E equals to R. You can take any subset. In fact, you can take any non-empty subset. Any non-empty subset. This is always less than or equals to what? 1. 1 is less than what? 2. Therefore, this is contained in some ball sent at A with radius 2 for every y belongs to E. Right? Therefore, any ball, any set which is contained in the ball sent at A, some center at A with radius 2. Because you know that R is an uncountable set. We can pick at least one member in R. Therefore, with this R, this is true. Therefore, distance between x comma A should be less than 2. Therefore, this is true for every y in E. Therefore, this is contained in the ball center at A comma 2. Is it clear? So therefore, what you observe, any subset of discrete metric space is bounded. That means E contains some ball centered A with radius bigger than 1. In fact, is it clear? So therefore, this is bounded. Not only this, so this is my with respect to discrete metric, right? This is my first one. What is my second one? Is it bound? Is it open with respect to usual? Open 0, 1. My set is open 0, 1. Is it open with respect to usual metric? Is open 0, 1. Is it open with respect to usual metric?
Yes, sir.
Yes. Is it closed with respect to open 0, 1? Is it closed? No, because 0 is a limit point. 0 does not belongs to set, therefore not closed. 0 is a limit point, but 0 does not belongs to set, so therefore not closed. Is it dense with respect to usual metric? Is it dense with respect to usual metric? No, because E closure is nothing but what? Close 0, 1. It cannot be full R. Therefore, it cannot be dense in with respect to R with respect to usual metric. Is it perfect? No, because what are my limit points? My limit points are nothing but what? For open 0, 1, my limit points are 0 is my limit point, inside point is limit point, 1 is limit point, but outside points are not limit points. So my limit points are close 0, 1. This is not same as saying that E. Therefore, derived set is not itself set itself. Therefore, it is not perfect. Is it bounded in usual metric? Yes, because it has a lower bound 0, upper bound 1. Therefore, it is bounded. Is it clear, sir? Difference? Did you understand the difference? Did you understand the difference? Suppose you can take another one. Suppose my set is actually what? Suppose you can take Q, rational numbers. Question is that, is it open in discrete? Is it open in discrete? Is it open in discrete? Yes. In discrete metric space, it is always open. Because any subset of R with respect to discrete metric is always, my set is R. My set with respect to this is a discrete metric. This right side, this is usual metric. Question is that, is it open with respect to discrete? Yes, the answer is yes, because any subset of R with respect to discrete is always open. Is it closed with respect to discrete? Is it closed with respect to discrete? The answer is yes, because any subset of R with respect to discrete is always closed. Is it actually bound? Is it actually dense? Is it actually dense? No, because my derived set is what? My derived set is empty. Empty cannot be full Q. Full R. In empty cannot be full R. Therefore, not dense. Not dense. Right? Means no. Right? Is it bounded? Already told you. Any subset of discrete metric space is bounded. Any subset of discrete metric space is bounded because my radius is more than 1. I can fix my center at least 1 because R is countable. I can fix my center. Right? So is it perfect? Is it perfect? The answer no. Yes or no? This closure here, sorry. Closure is what? Closure is itself. But it cannot be R. Therefore, what is my, is it perfect? No, because derived set is empty. Empty cannot be E itself. Therefore, not perfect. Question is, in usual, right? Is it open? Rational numbers, is it open? No, right? Is it open? Bro, right? In suppose 2, if you take 2, 2 is rational. Is it interior point? No, because I can find at least one. You take any neighborhood around 2, it cannot be sitting inside 2. Therefore, 2 cannot be limit point, 2 cannot be interior point of Q. Therefore, at least one point which is not interior point means what? 2 is a rational number. So 2 cannot be interior point of Q. Why? Because you take any neighborhood, it contains irrationals and rationals, which is not contained in Q. Rationals, of course, in Q, but irrationals should not be in Q. Therefore, any neighborhood which could take around 2 does not contain in the set in Q. Therefore, 2 cannot be interior point. Therefore, at least one point is not interior means not open. Right? Is it closed in Q? Is it closed in R with respect to visual? The answer no, because if you take root 2 is a limit point, because any neighborhood you take, it contains irrationals and rationals. Any neighborhood you take, it contains at least one rational other than this point. Therefore, root 2 is a limit point of Q, whereas root 2 does not belongs to Q. Therefore, not closed. Right? Because root 2 is a limit point, because any neighborhood you take, it contains at least one rational. Any neighborhood, it takes very small neighborhood. You take any small neighborhood, it contains at least one rational. You take very small neighborhood, any small neighborhood, any teeny neighborhood, it contains at least one rational other than root 2. Therefore, root 2 is a limit point of Q, but root 2 does not belong to Q. Therefore, Q does not contain all limit points, means at least one limit point, does not contain at least one limit point. So therefore, not closed. Next, dense. Is it dense?
Yes, sir.
Yes, because why? Because Q closure is nothing but what? Q union its derived set. So Q union, what is my derived set with respect to visual metric? What is my derived set? Every point is a limit point. Every real number is a limit point, because you take any real number, you start with any neighborhood, it contains at least one point other than A. Any neighborhood you take, it contains at least one point other than A. Therefore, A is a limit point. What is A? A is arbitrary limit point. Therefore, any real number is a limit point. Therefore, what is my Q union R? R itself. Therefore, it is dense. Question is it bounded? Is it bounded? No, because if it is bounded, natural numbers also bounded automatically. Subset of bounded is bounded. Therefore, natural number, is it bounded? No, right? Because by Archimedean property, it is not bounded. If it is Q bounded, automatically N should be bounded, because N is after all a subset of Q. Therefore, by Archimedean property, N should not be bounded. Contradiction. Therefore, not bounded. Is it perfect? Is it perfect? What is the derived set of Q? What is the derived set of Q? Rationals. Real numbers. What is my derived set? Real numbers. Yes or no? Because I already told you, every real number is a limit point. So what is the derived set? Total R. Is it Q? Is it full Q? No. Derived set of Q is equals to R. R should not be Q. Therefore, derived set of Q, it should not be itself. Therefore, not perfect. Is it clear? Difference between discrete and visual. Difference between discrete and visual. Right? Shall I continue more example or something else? Shall I go to another topic? Shall I move to another topic? Or can I give in one more example?
Not to, sir. Not to.
Not okay. Third example. Auto with respect to discrete. This is my one phase. What is my second phase? Suppose D2. Euclidean metric. Suppose you can take any set. Suppose for sake of convenience, you can take any simple set like x-axis, y-axis. Right? It's subset of R. Question is it open in discrete? As already told you, any subset of discrete is open. Is it closed? The answer is yes, because any subset of discrete is closed. Is it bounded? The answer is yes, because any subset of discrete is bounded. That are the features of discrete, right? Right? It is open, closed, bounded, right? But it should not be compact. I'll tell you later. So therefore, it is closed and bounded. Open. Next, is it perfect? No, because what is my derived set? Empty. Empty should not be E. Right? Therefore, it should not be perfect. Is it dense? Is it dense? Is it dense? No, because the closure is itself. Because E is a closure set. You take any subset of R2, You take any subset of R2 that is closed. Whenever that is closed, the closure of the set is itself. It cannot be R2. So any subset of set, you take the closure, it should not be R2. Any subset, you take any subset, closure is itself because E is a closed set, but it should not be R2. That means what? Any subset that you take, that should not be dense in R2 with respect to discrete. Right? So question is next, is it open in usual? Is it open?
No, sir.
No. So right, because this is my point, these are my points. So therefore at least 0 is not interior point. At least 0. At least 0 is not interior point. Of course any point also not interior point. So not open. Next, is it closed? The answer is because it contains all its limit points. Every point on the line is a limit point because any point you take, it contains at least one point other than the point itself. Therefore, it is a limit point. You take any point, you take this point, any neighborhood you take, it contains at least one point on the line other than the point itself. Therefore, it contains all its limit points. Answer is it bounded? Is it bounded? The answer no. If it is bounded, positive real line also positive. This line is also, if it is bounded, understand, if y-axis is bounded, this to this also bounded, positive real line. If positive real line is bounded, natural numbers are bounded. If natural numbers are bounded, contradiction, Barkman property, hence it should not be bounded. Right? Now is it perfect? Is it perfect? What is my derived set? My derived set actually what? My derived set is every member is a limit point of the set. This member, every member is a limit point. Is it a limit point? No. You take any neighborhood, does not contain any point of the line. Therefore, none of the points outside are limit points. Therefore, what are the only limit points? The only points which are of the limit points are the points in a set itself. Therefore, derived set is itself. So therefore, it's always perfect. Is it dense? Is it dense? Is it dense? Is it dense? No, right? Because the closure is itself. It should not be R2. Why closure is itself? Because E is a closed set. E closure is itself. Therefore, E should not, that E should not be in R2 because this E is a proper subset of R2 because this is just after all a line in a plane, in a total plane. This y-axis after all a line, just after all a line. It should not be full R2. It should not be full R2. Therefore, it should not be dense. Is it clear? Yes. Hello.
Okay,
Is it clear?
Okay, okay, sir. Go to next.
Okay. So next is
ఒకసారి
next
empty
set.
set గురించి చెప్పరా సార్? empty set గురించి ఒకసారి ఇదాన అయిపోరా సార్? empty set
integers, huh?
empty set సార్.
Empty set, okay. Empty set always both open closed. Both open closed. Is it dense? Is it dense? No. The closure itself, because it is closed, closure is itself, it should not be metric space. Therefore, it should not be dense. Is it perfect? What is the derived set? Empty. Is it perfect? Answer yes. Is it bounded? Yes. Right? ఇంకేమైనా ప్రాపర్టీస్ ఉంటే చెప్పండి, డిస్కస్ చేద్దాం. What is interior of a set? Because empty set is open, interior of a set is itself. Interior is empty. Because why interior is empty? Because empty set is open, interior of a set is empty. Right? Every point is interior point, but a point, there are no points, therefore interior must be empty. If you give me points, I'll check that whether it is interior or not. So there is no point means what? You can assume that interior is empty set. Is it clear?
Okay, thank you sir. Clear sir.
X also, X itself also both open, both closed. X also both open and closed. Right? X also, any metric space itself is a both open and closed set. Why? Because you take any point you take, I can find at least one neighborhood which is inside the set. Therefore, every point is interior point. Is it interior point? Yes. I can adjust neighborhood which is inside the set. Therefore, which is an interior point. So what you observe, every point is interior. Is it closed? Yes, because every point is a limit point which is inside. Every point you take, any neighborhood you take, it contains at least one point other than itself. Is it a limit one? Yes, because you take in a neighborhood, it contains at least one point other itself. Therefore, that is also limit point. So of course, it contains all its limit points. These are the limit points which are inside the set. Therefore, it is closed also. What is the derived set? X itself. What is the interior set? X itself. What is the closure of the set? What is the closure of the set? X is closed, therefore closure is itself. Yes or no? Is it bounded? See, it may be bounded or may not be bounded. May be bounded according to metric. Understand? May be bounded, may not be bounded. Understand? According to metric. According to metric that you are given. If it is discrete, that is bounded. If it is somewhere, suppose you can take like this. Okay. Nice question. Suppose your set is this. Your set is this. Suppose your metric is this. Minimum of 1 comma mod of x minus y. Suppose 100. Is it bounded? Is it bounded? Suppose x equals to r. Is it bounded? Is it bounded metric space? Suppose if you take e equals to natural number, is it bounded? The answer yes. Because I already told you this is less than or equals to 100. Minimum of 100 comma mod x minus y. This is less than or equals to 100. This is true for every point which are in a metric space. Right? Of course, I can take 101. Therefore, this is true for every y. In particular, I can take y equals to 0. Right? Therefore, x is see distance between x comma 0 is less than 101 means what? X should be in a ball centered 0 comma 101. This is true for every axis. Therefore, what you observe, every real number that you take, that is inside the ball. That is inside the ball. Therefore, this R is bounded. R is bounded with respect to this metric. R is bounded. That means full metric space is bounded with respect to this minimum of this metric space. With respect to minimum metric means already I told you in basic classes. This is a metric. It's a bounded metric because you know R is inside the ball. Therefore, R is bounded. Is natural numbers is bounded because always bounded because natural numbers contain R contains natural number. Therefore, n is in this. Is integers bounded? Yes, because Z is inside R, R is inside ball. Therefore, Z is bounded. So that means what? Full matrix space bounded means what? Every subset also bounded. Is it clear? Hello, is it clear?
స్మాల్ డౌట్
Tell me.
అది ఓపెన్ క్లోజ్ అన్నప్పుడు అది సెమీ ఇంటర్వెల్ మీద కూడా డిస్క్రీట్ మెట్రిక్ స్పేస్ అవుతాయి సార్ ఎట్లా డిఫైన్ చేస్తారు
Open brace,
ఓపెన్ ఇప్పుడు సెమీ ఇంటర్వెల్స్ ఉంటాయి కదా సార్ ఫర్ ఎగ్జాంపుల్ క్లోజ్ 0 ఓపెన్ 1
same half open intervals,
హాఫ్ ఆఫ్ ఇంటర్వెల్స్ మీద హౌ విల్ డిఫైన్ ద డిస్క్రీట్ అండ్ మెట్రిక్ అంటే మీరు
మీది సెట్ ఈ సబ్సెట్ ఇదా?
ఈ సెట్ అదే సార్ ఈక్వల్ టు సపోజ్ క్లోజ్ 0 ఓపెన్ 1
మై మెట్రిక్ స్పేస్ ఇస్
యూజువల్ మెట్రిక్ ఆర్ డిస్క్రీట్
ఏది తీసుకుంటారు మీరు? ఫస్ట్ ఏది తీసుకుంటారు చెప్పండి. డిస్క్రీట్ మెట్రిక్. ఓకే, ఇప్పుడు మీ డౌట్ చెప్పండి.
అంటే ఇప్పుడు ఈ ఈక్వల్ టు క్లోజ్డ్ 0 1 మీద అది డిస్క్రీట్ మెట్రిక్ అవుతుందా? మీరు ఓపెన్ క్లోజ్డ్ అని చెప్తారు కదా సార్.
ఇది ఓపెన్ క్లోజ్డ్ అయిద్దా అని అడుగుతున్నారా? ఆల్వేస్ అవుతుంది. ఎనీ సబ్సెట్ దట్ యు టేక్ ఇన్ డిస్క్రీట్ ఆల్వేస్ ఓపెన్, always closed. That's what my point. No, any subset that you consider closed, bounded, and closed, open, and of course bounded also. You check చేయాల్సిన అవసరం లేదు, కళ్ళు మూసుకొని ఆన్సర్ పెట్టండి. డిస్క్రీట్.
సో అంటే హాఫ్ ఇంటర్వెల్స్ కూడా అది ఓపెన్ క్లోజ్డ్ అండి.
మీరు ఆఫ్ అని కాదు సార్, యు టేక్ ఎనీ సబ్సెట్ దట్ యు టేక్ ఎనీ సబ్సెట్, యు టేక్ ఎనీ సబ్సెట్, random subset, race, intervals, everything that you take, everything. Any subset that you consider uncountable or countable, finite or infinite, every set that is open, closed, bounded. ఇవి మూడు చెక్ చేయాల్సిన అవసరం లేదు, చూడగానే ఆన్సర్ పెట్టండి అంటున్నాను.
ఓకే సార్.
That's what. Okay. Suppose you can take this metric. This is a different metric. Suppose R with respect to d of x comma y is equals to mod of x minus y by 1 plus x minus. Is it bounded? Is R bounded? Is it a bounded metric space? You're asked to find is it bounded or not? Is it compact or not? Of course, compact ఇంకా కాలేదు కాబట్టి నేను డిస్కస్ చేయట్లేను. Yeah, is it bounded? The answer yes, because mod of x minus y is bigger than or equals to 0. Any mod is always bigger than or equals 0. This 1 plus is always, this is true, right? Yes or no? Therefore, what you observe? This is 1 by mod of x minus y should be less than or equals to 1. If you multiply with modulus, the inequality doesn't change. Yes or no? So that means what I'm trying to say is this value is less than or equals to 1. In fact, this value is less than or equals to. This value is less than or equals to 1 by something is less than or equals to 1. Yes or no? Right? In fact, you can write it as, you know, this can be written as yes or no? Yes or no?
Yes, sir.
Yes. You know, this is a positive quantity, should be less than 1. Which is positive quantity always less than 1. Yes or no? It's a positive quantity. So 1 minus positive quantity is always less than 1. So what you observe is this distance between x comma y should be less than 1 for every x, for every y. So therefore, for the same logic, which is inside the ball center 0 comma 1 for every x in R. In fact, this R is contained in the ball center 0 comma 1 with the same logic. If I take y equals to 0, right? So R is inside the ball means R is bounded with respect to this metric, with respect to that metric. So R bounded means any subset of R is bounded. Natural numbers, integers, everything. So చాలా మంది కన్ఫ్యూజ్ అయ్యేది ఏంటంటే జెడ్ అంటే బౌండెడ్ కాదని, న్యాచురల్ నెంబర్స్ అంటే బౌండెడ్ కాదని, రైట్ రైట్ ఇంకా రేషనల్ నెంబర్స్ అంటే బౌండెడ్ కాదని, రైట్ ఇంకా ఈవెన్ నెంబర్స్ అంటే బౌండెడ్ కాదని, రైట్ ఇంకే నెంబర్స్ అయినా చూడడానికి అది ఇన్ఫైనైట్ సెట్ అయితే సంథింగ్ లోవర్ బౌండ్ ఉండదు అన్న. సో అది రాంగ్. సో వాట్ ఈస్ యువర్ గివెన్ మెట్రిక్, దట్ ఈస్ ఇంపార్టెంట్. In which metric you are working, that is important. So according to metric, the answer will be depend. According to your metric, the answer will depend. Yes or no? Is it clear? I hope you understand.
Sir.
So కాబట్టి మెట్రిక్ మీద మనం వర్క్ చేసిన తర్వాత మాట్లాడాలి. So that's what actually thing, right? Next is if you take boundary of a set. Right? Again, you start with the metric space. Right? You start with any subset of a metric space. Right? What is the boundary of a set? Generally denoted by, there are two notations. Generally, in international notation, this is the international notation. Boundary of a set is nothing but dou of E. In some books, they mentioned that this is B of E. Whatever notation you follow it. So dou of E is defined by the closure of the set intersection with closure of the complement. Right? Means boundary of a set which I denoted by dou of E, that is nothing but a closure of a set, closure of the set, just wait. Right? Closure of the set is a closure of the set intersection with closure of the complement. So this is what my definition. This is what my definition. Right? Suppose you can take R with respect to visual metric for understanding purpose. Suppose I can take this open 0, 1 for simplicity. What is my boundary of a set? We're asked to find what is meant by boundary of a set. What is my boundary of a set? You know what I'm telling you is that what I'm telling you means any boundary of a set is nothing but a closure of the set intersection with the complement of the closure of the complement. Yes or no? So therefore, what is meant by boundary of a set means closure of the set, closure intersection with closure of the complement. What is the closure of this? Closure interval 0 to 1. What is the complement? What is the complement of this? What is the complement of this?
Minus
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 infinity is
infinity
0.
is 0 close.
1 comma infinity.
1.
Right? What is the closure of this? Anybody? What is the closure of this? It's a closed set. Is itself. Yes or no? Because it's a closed set. Minus infinity to 0. Union 1 to infinity is a closed set. Once it is a closed set, complement is itself. Closure of the complement is itself. Yes or no? Therefore, what is this? What is this? Is it clear? Is it
Yes,
clear?
sir.
Yes. So again, intersection is distributed over union. This intersection is a long procedure, but I'm going to give a very shortcut. So again, union, this closed in interval 0 to 1, 1 to infinity. So what is intersection with closed 0 to 1? Closed 0 to 1, intersection with closed interval 0 to 1, intersection with minus infinity to 0. This intersection with this, only 0, right? Union. What is intersection? Closed interval 1 to infinity, 1 only. So what is this? What is this? 0, 1. Is it clear? Yeah.
Okay, sir.
But the thing is, this is very, very fast method. You don't follow this method. I'm going to give simple technique. Thing is, actually, what is my definition? First, look at the definition. So any point you take that is a boundary point, if or knowledge, that should be in the closure as well as the complement of the closure. That is if or knowledge, that should be in a closure as well as the closure of the complement. So X is in closure means according to topology, but you don't know topology right now, but you need to remember this point. Any point that in is closure, so any neighborhood of that X which should intersect E as well as any neighborhood of X which should intersect complement also. Any neighborhood in intersect Jl as well as E complement intersect Jl. When do you want to say that? When do you want to say that X is a boundary point? Any neighborhood that you take around that X which intersects E as well as which intersects the complement. Is it clear? In intersect Jl as well as complement would intersect Jl. That means any neighborhood that you take, suppose for this example, same example, look at the same example, E equals to 0, 1 in R with respect to usual. Right? So this is my actually orientation. Is it a boundary point? No, because I can find some neighborhood which intersects the complement. This is my complement actually. This region is complement of the set, including 1 also. Okay, so this point, is it a boundary point? No, because it intersects the complement but should not intersect C. It should not intersect E. Yes or no? Is it clear? So it cannot be boundary point. Yes or no? Right? Is it a boundary point? No, because this neighborhood, I can find some small neighborhood which intersects the complement but should not intersect C. Is it a boundary point? No, because you take any small neighborhood which intersects the complement but should not intersect E. Is it a boundary point? No, because you take any small neighborhood which intersects E, which intersects the set E, but not complement. Therefore, it cannot be limit point. So outside points and inside points are not boundary points. But 0, the answer is because you take any neighborhood, it contains the complement. This red region is a complement and black region is a set. This is my set. So any neighborhood that you take intersects left region as well as right region. Left region is a complement, right region is a set itself. Therefore, 0 is a boundary point. Here, you take any neighborhood, it contains right region is intersects complement. This is my right region. It intersects as well as the set itself. So left region. Therefore, 0, only are the boundary points. Is it clear? Hello? Is it clear?
Yes, sir.
Suppose you can take any example 1 over n such that n belongs to n. What are my boundary points? What are my boundary points? 1, 1 by 2, 1 by 3, going on. Is it my boundary point? No, because it intersects the complement, but should not be intersect set. Is it a boundary point? No, it should intersect complement, but not E. Is it a boundary point? Yes, because any neighborhood you take, it intersects E ని intersect చేస్తుంది. ఎక్కడ 1 దగ్గర intersect చేస్తుంది. ఈ neighborhood లో 1 ఉందా లేదా? ఈ 1 E లో ఉందా లేదా? Yes. So this neighborhood intersects set E, of course complement also, because this is the right region and left region. Therefore 1 is a boundary point. Is middle point is a boundary point? No, it intersects complement, but should not intersect set itself. Is 1 by 2 is a boundary point? The answer yes, because intersects set itself as well as complement also. Is it boundary point? The answer is because intersects complement as well as the set. Set ని ఎక్కడ intersect చేస్తుంది? 1 by 3 దగ్గర intersect చేస్తుంది. Is 0 is a boundary point? Is 0 is a boundary point? Yes. You take any neighborhood, intersects set as well as the complement. So 0 also boundary point. Any point which is less than 0, is it? No, because it should intersect the complement but not E. So what are my boundary points? What are my boundary points set together with
including 0.
0?
సార్ 1/2 ని ఎలా ఇంటర్సెక్ట్ చేస్తుంది సార్?
1/2 1/2 లో 1/2 ఉంటది కదా సార్ ఈ ఇంటర్వెల్ లో.
ఉంటుంది సార్. అంటే కాంప్లిమెంట్లలో సార్.
కాంప్లిమెంట్ మీరు స్మాల్ తీసుకోండి. మీరు ఎంత చిన్న డ్రా చేసినా ఇందులో రేషనల్స్ ఉంటాయి కదా. రేషనల్స్ అనేది కాంప్లిమెంట్, ఇర్రేషనల్స్ అనేది కాంప్లిమెంట్. ఒకటి ఉంటే చాలు ఇర్రేషనల్ కానీ. ఎంతనో?
ఓకే సార్, థ్యాంక్ యూ సార్.
Okay, right. So this is my boundary of a set. Suppose you can take in R2 for this idea. Okay, for understanding purpose, discrete తీసుకోండి. చాలా మంది ఇక్కడే కన్ఫ్యూజ్ అవుతున్నారు. సో రైట్, యూ కెన్ టేక్ E ఈక్వల్స్ టు మీ ఇష్టమైన సెట్ ఏదైనా తీసుకోండి, ఇదే సెట్ తీసుకోండి అండర్స్టాండింగ్ పర్పస్. ఒక్క ఎగ్జాంపుల్ పర్ఫెక్ట్ అర్థమైతే దెన్ యూ కెన్ ఎక్స్టెండ్ ద ఐడియా టు వెరీ ఎగ్జాంపుల్. క్వశ్చన్ ఇస్ వాట్ ఆర్ ద బౌండరీ పాయింట్స్? నేనేమన్నాను? ఎవ్రీ నైబర్హుడ్ దట్ యూ టేక్ దట్ ఇంటర్సెక్ట్స్ బోత్ E యాజ్ వెల్ యాజ్ ద కాంప్లిమెంట్. ఇప్పుడు 0 దగ్గర నేను నైబర్హుడ్ రాయిస్తే ఎవ్రీ నైబర్హుడ్ రాయిస్తే ఇంటర్సెక్ట్ కావాలి. నేను ఏమి ఇస్తాను? సింగిల్టన్ ఇస్తాను. సింగిల్టన్ ఇస్ ఎ నైబర్హుడ్. డస్ ఇట్ ఇంటర్సెక్ట్స్ కాంప్లిమెంట్? ఈవెన్ సెట్? నో. ఈ 0 అనేది సెట్ లో ఉందా? లేదు. యాజ్ వెల్ యాజ్ కాంప్లిమెంట్ ఉంది, ఇంటర్సెక్ట్ చేస్తుందా? లేదు. సో 0 కెనాట్ బి బౌండరీ పాయింట్. ఇస్ ఇట్ ఏ బౌండరీ పాయింట్? నో. వాట్ ఈస్ మై నైబర్హుడ్? ఏ. ఇస్ నో? సింగిల్టన్ ఏ. సింగిల్టన్ ఏలో ఈ పాయింట్స్ ఉన్నాయా? సెట్ పాయింట్స్ ఉన్నాయా? లేవు. యాజ్ వెల్ యాజ్ కాంప్లిమెంట్ ఉన్నదా? లేదు. కాంప్లిమెంట్ అంటే ఇవన్నీ కాంప్లిమెంట్ ఇంటర్సెక్ట్ చేస్తా. అఫ్ కోర్స్ ఏ ఇంటర్సెక్ట్ చేస్తా అనుకో, కాంప్లిమెంట్ అంటే ఏ ఒక్క దగ్గర ఇంటర్సెక్ట్ చేస్తుంది, బట్ సెట్ లో పాయింట్స్ లేవు కదా. కాంప్లిమెంట్ ఇంటర్సెక్ట్ చేస్తుంది, బట్ ద థింగ్ ఇస్ సెట్ లో పాయింట్ ఇంటర్సెక్ట్ చేయడం. దేర్ఫోర్
0 సెట్ లో లేదు, 0 కాంప్లిమెంట్ లో ఉంటుంది కదా సార్.
0 కాంప్లిమెంట్ లో ఉంది, 0 కాంప్లిమెంట్ లో ఉంది, సెట్ లో ఇంటర్సెక్ట్ చేయదు కదా. రెండింటిని ఇంటర్సెక్ట్ చేయాలి. ఇస్ ఇట్ క్లియర్? ఇది యాక్చువల్లీ ఏంటి? కాంప్లిమెంట్ ఇంటర్సెక్ట్ చేస్తుంది. అండర్స్టాండ్?
ఓకే సార్, ఓకే.
బట్ సెట్ ని ఇంటర్సెక్ట్ చేయదు. సో సపోజ్ యూ కెన్ టేక్ ఇన్సైడ్ పాయింట్స్ తీసుకోండి. ఇన్సైడ్ పాయింట్ తీసుకుంటే యాక్చువల్గా అగైన్ సేమ్ సింగిల్టన్ తీసుకోండి, జస్ట్ సింగిల్టన్ యాజ్ ఎ నైబర్హుడ్. ఇది సెట్ ని ఇంటర్సెక్ట్ చేస్తుంది కానీ కాంప్లిమెంట్ ఇంటర్సెక్ట్ చేయదు. సో ఏ కెనాట్ బి లిమిట్ పాయింట్. ఇస్ ద పాయింట్ ఏ బౌండరీ పాయింట్? నో, బికాస్ ఇది కాంప్లిమెంట్ ఇంటర్సెక్ట్ చేస్తుంది కానీ సెట్ ని ఇంటర్సెక్ట్ చేయదు. ఎస్ ఆర్ నో? సో వాట్ ఆర్ మై బౌండరీ పాయింట్స్? What are my boundary points? Empty. Is it clear? Yes. Again, boundary of a set is nothing but closure of the set intersection with the closure of the complement. It is always closed set. Yes or no? In any matrix space. Why? Because closure of the set is closed. Right? This is also closure. This is also closed. Arbitrary intersection of closed is closed. So boundary of a set is closed. So E is closed. So next argument, the closure of the set is nothing but E union its boundary. This is another argument. Right? You take any subset of a metric space. E closure is nothing but union boundary. Suppose you can take anything. See, గుర్తుపెట్టుకోండి boundary గుర్తుపెట్టుకోవాల్సిన అవసరం లేదు, right? See, closure of the set is closed. This closure is closed. Intersection is always closed. Arbitrary intersection of closed is closed. So boundary of a set is always a closed set. Suppose ఇది తీసుకున్నారు అనుకోండి, R with respect to usual తీసుకోండి. మీరు ఏది తీసుకున్న ట్రూ అవుతుంది. Of course, this is a general statement. Suppose open 0 1 తీసుకోండి, సింపుల్. జనరల్ గా ఈ క్లోజర్ అంటే ఏంటి? మన ఆర్గ్యుమెంట్ ప్రకారం యూనియన్ ఇట్స్ డిరైవ్డ్ సెట్. వాట్ ఈస్ ఈ? Open 0 1 union. What are my derived set? What is my derived set? Close 0 1. Therefore close 0 1. Yes or no? What are my limit points? 0 including all points. 1 also. So what is union? Close 0 open 1. Close 0 close 1. According to this problem, what is my derived set? What is my closure? Union means union its boundary. What is E? Open 0 1. What is the boundary? With respect to usual. So therefore, what is this? Close 0, close 1. So both are same. Is it clear? E closure is nothing but E union its boundary points. That is right. E closure is equals to E union its derived set. That is also right. Both arguments are right. This both are right. Is it clear? Right?
Not doubt, sir.
Tell me.
Any boundary set, boundary point may exist, may not be.
Hello. గట్టి మాట్లాడండి. హలో సార్, నాకు వినిపిస్తలేదు.
బౌండరీ సెట్ అని మనం డిఫైన్ చేసిన తర్వాత బౌండరీ పాయింట్ కంపల్సరీ ఎగ్జిస్ట్ కావాలని రూల్ ఉంది.
లేదు, ఇక్కడ తీసుకో. ఇక్కడ డిస్క్రీట్ లో బౌండరీ పాయింట్స్ ఉన్నాయా? లేవు. బౌండరీ పాయింట్స్ ఉండాల్సిన అవసరం లేదు ఒక సెట్ కి. డిస్క్రీట్ మెట్రిక్ స్పేస్ తీసుకో. అలా సెట్ ఏదైనా తీసుకో, దానికి బౌండరీ పాయింట్స్ ఉండవు. Is it clear?
ఓకే సార్.
Okay. Right. Suppose exterior of a set means exterior point, exterior of set. You start with again metric space. You start with any subset of X. Right? Exterior of a set is denoted by like this. My definition is interior of the complement. Interior of the complement. This is my definition. Interior of the complements, interior set of the complement of the set. Right? So suppose we start with usual. Right? These are the standard definition according to Siemens and Rodin. Right? So suppose you can take any set you take. Suppose start with open 0 1. What is my exterior of a set? Anybody? You are asked to find exterior. What is my exterior? Interior of the complement. Yes or no? Interior of the. Look at the first complement. Look at the complement. So what is the complement? What is my complement? This is my complement. Yes or no? So what is the interior of the set? Anybody? What is the interior of the set? What is the interior of the set? What is the interior of the set? Oh, 0 cannot be limit point. This point is a limit point. See, this 0 cannot be interior point because any neighborhood take some region is outside, right side region. Therefore, 0 cannot be interior point. Is it interior point? Yes, because we can adjust a neighborhood which is inside. Is it an interior point? Yes. Is 1 is interior point? No, because some left region is outside. Is it interior point? Yes. So what are my interior points of the complement? Minus open, minus
Open
infinity,
0.
open 0, open 1, infinity. What is this? Exterior of A. Is it clear? Suppose you can take the same R with respect to you. Yes. Suppose you can take Mr. Medana this one, finite set this one for sake of our convenience. Right? So what is exterior of a set? Exterior of set కావాలంటే first complement చూడండి. What is the complement of the set? What is the complement? 1, 2, 3. What is the complement? This excluding this and this and excluding this with excluding 3. This is my complement. Question is that what is the interior of this? Anybody? You know, this is open set because it's an open interval. This is an open set. This is also open interval. This is open set, open interval. Therefore, union of open set is an open set. Hence, complement is interior itself. Because E complement is open now. Why? Is an open, it's an open, it's an open. Union of open set is an open. Therefore, E complement is open. Once E complement is an open, interior set is itself. So this is what is exterior? E complement. What is E complement? This is my exterior of a set. Is it clear? Hello? Hello?
Okay,
Yes?
sir. Okay, sir.
ఫాస్ట్ అని అనిపిస్తే కొంచెం చెప్పండి. ఓకే, మెసేజ్ చేయండి. ఫాస్ట్ అనిపించింది అనుకోండి, మెసేజ్ చేయండి. దెన్ ఐ కెన్ అండర్స్టాండ్. సపోజ్
స్మాల్ డౌట్ సార్.
చెప్పండి.
E01 అంటే ఈ కాంప్లిమెంట్ లో 0 ఉంటుంది కదా సార్?
ఈ కాంప్లిమెంట్ లో 0 ఉంది. ఈలో 0 లేదంటే ఈ కాంప్లిమెంట్ లో ఉంటది కదమ్మా.
అదే మరి ఈ కాంప్లిమెంట్ లో మరి -∞ టు క్లోజ్డ్ 0 రాయాలి కదా?
ఎక్కడ?
ఫస్ట్
పైన
ఎగ్జాంపుల్.
క్లోజ్ తీసుకున్నాను కదా ఇక్కడ.
ఓకే, తీసుకున్నా.
Hmm.
సో దాని ఇంటీరియర్ అంటే మళ్ళీ ఓపెన్
0 ఉండదు కదా. 0 ఉండదు కదా. 0 కెనాట్ బి ఇంటీరియర్ పాయింట్ కదా.
ఓకే.
ఇంకా డౌట్స్? ఓకే ఓకే. ఆర్ విత్ రెస్పెక్ట్ టు అగైన్ దిస్ ఎగ్జాంపుల్ డిస్క్రిట్. ఇదే ప్రాబ్లం డిస్క్రిట్ వర్క్ చేద్దాం. ఓకే, ఫస్ట్ వాట్ ఈస్ ద కాంప్లిమెంట్? ఎనీబడి? One is a complement. This is my complement. Okay, what is interior of the complement? Anybody? See, you are working in discrete. So any subset of a metric space, discrete metric space is open. That means this is open. Once it is open, interior of the set is itself. Therefore, what is this? -∞ is 0. This. So what is my exterior? This one. Is it clear? Because complement of the set is after all a subset of R. Yes or no? It is after all a subset of R. It's a dummy set. Therefore, any subset of R always open. Once it is open, interior set is itself. Yes or no? Yes? Is it clear? Shall I move? Yes.
Yes, sir.
Suppose for learning purpose, you can take another example. Or with respect to discrete. You can give any example. Suppose you can take equals to 1 by n. What is exterior? Anybody? What is exterior? What is exterior? First of all, what is my set actually? My set is 1, 1 by 2, 1 by 3, going on, going on. Right? That means my set is 1, 1 by 2, 1 by 3. Right? 1 by ఇది అంతా కనుక్కోవాల్సిన అవసరం కూడా లేదు. ఇన్ఫాక్ట్ కరెక్ట్ చెప్పాలంటే రైట్ థింగ్ ఏంటంటే కాంప్లిమెంట్ అయిపోతుంది ఆటోమేటిక్గా. రైట్, 0 ఉండదు. రైట్. సో వాట్ ఈస్ మై కాంప్లిమెంట్? ఎనీబడి? What is my complement? My complement is -∞ to close 0, -∞ to close 0, and union of
Open 1
n
to
equals to
open 1 to
1 by n and open 1 to infinity. Yes or no? Is it clear? See, middle piece లో వస్తాయి, మిడిల్ ఆర్గ్యుమెంట్స్ వస్తాయి. అంటే 1 by n plus 1 to 1 by n. ఈ మిడిల్ టర్మ్స్ వస్తాయమ్మా, ఈ మిడిల్ పీసెస్. సో దిస్ ఇస్ యూనియన్. ఎస్ నో? ఈ అవుట్ సైడ్ వస్తుంది మళ్ళీ. అవుట్ సైడ్ అంటే ఇంక్లూడింగ్ 1, ఎక్స్క్లూడింగ్ 1. ఓకే, ఇట్ లెఫ్ట్ సైడ్ వస్తాయి ఇంక్లూడింగ్ 0, బికాజ్ 0 ఈలో లేదు కాబట్టి ఈ కాంప్లిమెంట్ లో ఉంటుంది. ఎస్ నో? ఇస్ ఇట్ క్లియర్? సో కళ్ళు మూసుకొని ఆన్సర్ రాయండి. ఈ కాంప్లిమెంట్ ఇంటీరియర్, ఈ కాంప్లిమెంట్ ఈజ్ ఈ కాంప్లిమెంటే. వేరే ఆన్సర్ లేదు, ఎందుకంటే ఇది డిస్క్రీట్ లో ఉంది కాబట్టి. ఎందుకంటే ఈ కాంప్లిమెంట్ ఈజ్ ఓపెన్, ఇంటీరియర్ ఆఫ్ ఈ కాంప్లిమెంట్ ఈజ్ ఈ కాంప్లిమెంట్ ఇట్ సెల్ఫ్, బికాజ్ ఈ కాంప్లిమెంట్ ఈజ్ ఓపెన్. సో exterior of E is nothing but same set. Yes or no? Is it clear? Did you understand this line? Yes. Okay. Right. Next is subspace. Suppose you are given a metric space. Question is that if I'm giving you a subset, can it be a metric space? Suppose X is a metric space. Suppose you are given a subset of a metric space. Question is that can it be a metric space? The answer yes. Right. So metric space కావాలంటే first metric why me the metric ఏంటి? Why metric space అయితే అయితే ఎందుకంటే because I'm taking the same metric delta where delta is equals to d, same d. So what is my metric? Delta is same as saying that d, same d. In fact, you can write it as like this, direct d. If d is a metric on x, y comma d is also metric space. Yes or no? Why? Same condition. If x comma d is a metric space, inheritance property, this y is a subset of x. So any metric that is acting on x automatically metric on y, because if x comma d is a metric space and y is a subset of x, automatically y is with respect to d is also metric space. Subset of a metric space is always a metric space. Why? Because you start with any elements you start with which are in y. What is my d of x comma y? Automatically non-negative, because any elements which are in x, y automatically in x. Any elements you take that in x, you know x is a metric space, distance is non-negative. And distance between x comma y is 0 if and only if x equals to y, because any x that you are taking in y automatically that are in x, therefore x equals to y. Distance between x comma y is equals to distance between y comma x, because that elements which are in x also, right? So again, you take any three elements which are in y, automatically that are in x. So automatically distance between triangle inequality. Is it clear? So what you observe? Subset of a metric space is always a metric space. Right? That means subset, any subset that you can take of a metric space is again a metric space. By inheritance property, by the same metric. Is it clear this step? Is it clear? Hello?
Yes, sir. Yes, sir.
Yes. But again, suppose X is a metric space, Y is also a metric space with a, see, suppose Y with respect to delta is a metric space where delta is same as saying D. Delta is nothing but D. Thing is, once it is a metric space, we can talk about openness. We can talk about closed set in metric. In this metric space. Again, we can talk about dense. We can talk about closure. Right? We can talk about bounded. We can talk about so many topological properties, so many metric properties. Yes or no? Because once y comma d is a metric space, whatever property we studied about the metric space, the same properties which you are going to study in this subspace, because it's a metric space. Once it is a metric space, you can talk about open set, closed set, dense set, separable, dense, all metric properties. Is it clear this step? First open ball, right? So relative open or open ball in this metric space. Suppose X is a metric space. Y is a subset of X. Suppose you take any point Y in Y. What is an open ball center at A with radius R with respect to subspace metric? Understand? This is the notation. Open ball center at A, radius R with respect to subspace with respect to subspace. This we call it as open related to y, or in some books included open ball relative to y, relative to y. So open ball relative to y equals to, what is the definition? What is the definition? Generally, set of all y metric space in y. You are working in y. You are working in y. Right now we forgot x because y itself is a metric space. Y itself is a metric space. So set of all elements in a metric space such that whose distance between y comma a is less than r. That means set of all y in y such that y is in distance between y comma a is less than r means what? Y should be in the ball centered a comma r. This is my open ball in full space. This is my open ball in subspace. Right? So set of all y in y that are in the ball. That means what? That is an intersection. The points are the set of all points in an open ball in X intersection with Y. So what is my idea? My open ball centered A comma R is nothing but this is an open ball in where? In Y. Open ball in Y is nothing but open ball in X intersection with Y. Open ball in X intersection with Y. Is it clear? So this is very, very important fundamental result in topology, of course, in metric space. Is it clear?
Yes, sir.
Open ball in Y. Open ball in Y is nothing but open ball in X intersection with Y. Is it clear? Suppose you can take R with respect to usual. Right? Suppose my Y is Q. You know, Q itself is a metric space. Q is a subspace of R with respect to this metric. Question is that suppose you can take A equals to 0. My radius is suppose 1. Question is that what is my open ball centered 0 with radius 1? Already told you is a minus R, A plus R. That means minus 1 comma 1. My question is, what is an open ball centered 0 comma 1? Means open ball centered 0 comma 1 intersection with Y. That means minus 1 comma 1. What is my open ball? Minus 1 comma 1 intersection with Y. That means minus 1 comma 1 intersection with Q. So it's an open ball in Y. It's an open ball in Y means Q. Is it clear? Is it clear, Amma? Hello?
Yes.
Right? Suppose you can take the same argument. Suppose Y equals to close 0, 1. My metric space is same R with respect to usual metric. Right? Suppose my A equals to 0, R equals to 1. What is my open ball centered 0, 1? Means A minus R, A plus R. This is my in X. This is my open ball in X, in R. Question is, what is my open ball centered 0 with radius 1 in Y? Means open ball centered 0, 1 intersection with Y. That means what? Minus 1, 1 intersection with what is Y? Close 0, 1. You know, this is my actually minus 1, 1. This is my close 0, 1. So what is intersection? What is the intersection? This region, including 0. Is it clear? Because చూడండి ఓపెన్ బాల్ అంటే -1 to 1 వచ్చింది ఇన్ ఆర్ లో. బట్ ఓపెన్ బాల్ ఇన్ క్లోజ్ 0, 1 లో యాక్చువల్లీ ఏమొచ్చింది ఓపెన్ బాల్? లెఫ్ట్ క్లోజ్డ్, రైట్ ఓపెన్ ఇన్ Y. Y means close 0, close. Is it clear? Hello?
Okay, sir.
Okay. Suppose I can take same Y is equals to close 0, 1, same R with respect to usual metric. Suppose my A is 1, my radius is 2. Right? What is my open ball centered 1 with radius 2? Means open ball centered 1, 2 intersection with Y. What do I mean by open ball centered 1 with radius 2? Means 1 minus 2, 1 plus 2 intersection with close 0, 1. That means 0, 3 intersection with close 0, 1. That means what is this? This is close 0, 1. This is close. This is what 3 actually. Right? So what is my intersection? What is my intersection? This total is intersection. Yes or no? What is my intersection? What? Yeah, sorry. Minus 1, right? Minus 1, sorry. So we can take minus 1, comma 3. Good. Okay. So what is my intersection? Okay, my definition is this. This is minus 1, comma 3 intersection with closed 0, closed 1. This is my one, which are inside. So what is intersection? What is intersection?
Closes 0, 1, 0, 1, closes 0.
Close 0, close 1. So that's what my open bar. Is it clear? Suppose you can take the same argument. Suppose my set is R, my space is discrete. So suppose my set is, you can take y is equals to same thing for understanding purpose. What is my open a equals to, for example, 0 with radius 1. So what is my open ball centered at 0 with radius 1? Open ball centered 0 with radius 1 intersection with y. Right? What is the open ball centered 0 with radius 1? Singleton 0. Intersection with 0. Yes or no? So what is intersection? 0. Is it clear? Are you getting it out?
Sir, how we got this one?
You know, you open ball centered 0, 1 with radius less than 1, no? Less than or equals to 1, no? In discrete, this is singleton 0, no? You know what is open ball centered R? In discrete, singleton A if R less than or equals to 1, full space if R is bigger than 1. Yes or no? You know, it is in discrete. Discrete means singleton 0 itself. Intersection with Y, close 0, 1. That means singleton 0. Yes or no? Is it clear? Hello, is it clear, sir? Hello?
Yes, sir.
Okay, sir. Okay.
Right. Suppose my set is same set, same discrete. My set is suppose 1 by n's. So what is my open ball? Suppose you can take, see any point you take that, you take not only single point, 1, 2, 3, 1 by 3 going on. My set is what? Actually, my set is in this counter y equals to close 0, 1 this counter. So E subset of y, okay. So what is my open ball? Centered 0, 1. Anybody? What is my open ball centered 0, 1? And discrete? Open ball centered 0, 1. Intersection with close 0, 1. Open ball centered 0, 1 actually what? In discrete. That is singleton 0. Intersection with this. That means what? Singleton 0. Is it clear? Is it clear?
Okay, sir.
Yes. You can take any point, of course. Now random, I'm taking random points. You can take any points. Suppose 1 by 2 is there. 1 by 2 is there. What is an open ball? 1 by 2 with radius 1. Yeah. What is an open ball? 1 by 2 intersection with y. So what is meant by open ball centered 1 by 2 radius 1? 1 by 2.
1 by 2.
Intersection with close 0, 1. What is this? 1 by 2. Is it clear? These are fundamental concepts. Once you know this concept, you can identify open, compact, connected, continuous, everything based on, already I told you, everything in topology and visual metric space, everything in complex analysis based on the only open sets and open balls. Every definition that you take that is related to open ball, open ball. Is it clear? Any doubts? Suppose you can take R2. Okay, R2 వస్తే మళ్ళీ కొంచెం ప్రాబ్లం అనిపిస్తుంది కదా. R2 D2 min. What is meant by open ball? What is meant by open ball? Suppose my A point, my set is, suppose my set is, okay, first quadrant. What is my set? My set is first quadrant. My E set is, yeah. What is my open ball? Suppose you can take A equals to 0, 0. My radius is 1. What does mean by open ball? Center at 0, 0 with radius 1. Means open ball center at 0, 0 with radius 1 intersection with y. That means what does mean by open ball center at 0, 0 radius 1? Already told you this is nothing but open circle center at 0, 0. You know what is the intersection with y? My y is this. My y is this. So what is intersection? Anybody? This black shaded region.
First
Sector.
quadrant.
Open sector, not including this curved boundary. This is like this, like this. This is my open ball. This shape is an open ball. Open sector does not including the curved shape, including this adjacent sides. This is my open ball, center at 0 with radius 1. Anybody? Any doubt? Is it clear? If వస్తే ఓపెన్నెస్ మాట్లాడొచ్చు, లేకపోతే మాట్లాడరాదు ఇక, రాదిగా ఫినిష్. ఓపెన్ బాల్ వచ్చిందా మళ్ళీ ఓపెన్ సెట్ వస్తుంది, ఓపెన్ సెట్ వచ్చిందా క్లోజ్ సెట్ వస్తుంది. ఇది రాకపోతే మళ్ళీ ఏది రాదిగా, ఎందుకంటే ఓపెన్ సెట్ రావాలంటే ఏంటి? అగైన్ ఎవ్రీ పాయింట్ ఈజ్ ఇంటీరియర్ పాయింట్. అగైన్ ఓపెన్ బాల్ ఎట్లా ఉండాలి? అప్పుడు ఇట్లా ఉండాలి, ఈ షేప్ ఓపెన్ సెక్టర్ లాగా ఉండాలి, లైక్ ఓపెన్ సెక్టర్. ఎస్ఎనో? హలో,
Okay, sir. Okay, sir. Now time.
టైం అయిందా సార్? టైం అయిందా?
7:10. 7:10.
ఓకే, ఇస్ దేర్ ఎనీ డౌట్?